Here we're going to look at virtual routing and forwarding, or VRF, and specifically we'll look at VRF Lite, or configuring VRF Lite. So most often VRF is used in service provider networks over MPLS. When it's not being used over MPLS or with MPLS, then we call it VRF Lite. So VRF Lite is the version not being used with MPLS. And basically what it does is it separates a router virtually. So I can have one router and I have multiple routing tables, interfaces within those tables and things like that. And it's very similar to VLANs, except for that it runs at layer 3. So we're pretty used to the traditional, we have a switch and we break it up. We put certain interfaces in the switch, we'll put it in certain VLANs, and we'll give those VLANs a number. So we could say here, let's see, like gig, hold on. So we could make this, say this is a gigabit interface here. Oh, move my pen over. So GI 01, GI 02, or gig 03, okay? And we've taken this interface and we've assigned it to VLAN 10. Very similar to what we're going to do with VRF. We're going to take these interfaces, let's say let's say it's gig 01, gig 02, 03, and 04. And we can assign them to a VRF instance. And I'll name that instance. So I'll name my instance, say, cust A for customer A. And I can name a separate instance. And I'll assign these interfaces to these VRF, to their separate VRF instances, just like I did with VLAN. So it's very similar in concept. The major difference, obviously, is that this is all layer 2, right? And this would be done on layer 3. So we'll break up this router, and actually I'm only going to break it in half when I do the actual configuration. I'll put these two guys in one VRF, and then I'll put these two guys in another VRF. Whoop, little off there. But I'm virtually separating this router, so these are in two different routing tables, forwarding tables, and whatnot, different sets of routing. And basically, we separate for whatever we need. Maybe we want to separate our data and voice this way. You could create some sort of separation for UC. But most often, service providers, as we already mentioned, maybe they want to separate out their customers. They want to use the same routing device, and then have a separate VRF for each of their customers. But fundamentally, even though it sounds like this really long name, it's like a layer 3, it's just a layer 3 segmentation in the same way that we did it with switches in layer 2 that we're pretty used to if you're watching this right now, probably. Couple things. It will, because they are separate instances of forwarding tables, you can use the same IP addresses. So, and specifically, I'll show you that. Whoops. Let me clear that off. What I think I'm going to use up here then is I'm going to use, so I can use 168.10/24. I'm going to use that here. I'm going to use 192.168.2.0.24 here. Remember I said I was going to put these two in the same instance, VRF instance, and I'll put these two in the same one. Since they're separate tables, I can actually reuse these subnets. So, not that I would send out private addresses to well, I could, but 168, 1.0, 192, 168. 1.0. So, 2.0, sorry. Now within the VRF, I wouldn't use the same addresses, but between them, here and here, I can use the same set of addresses over and over again because they're comprised of separate tables. Remember, if you keep this all, I'm sure you guys have had it happen to you before, if you keep this all as one, right, just traditional routing as we would normally do it, we connect the router up to all of its other routers, and they all have to have a different network. We always say every interface is a new network. And if you tried to do the same one, you'd get an address overlap message. Well, with VRF, we're breaking up. So this would be like two routers. The way I'm going to break it up would be like two routers. Two separate routers. The same thing we used to always say with switches. When we break up VLANs, it's like creating multiple switches. I could, if I wanted to put each one of these routers in a separate VRF, I could be virtually creating then 4 routers out of this one router. And in that instance, because it sees each of these sections, let's say, as a separate router, the addresses could be the same as if you had, or the addresses can be the same on each of these interfaces as long as they're in different VRFs, because it's like a separate standalone router connected out to the service provider, or connected out to the customer, sorry. So you can use multiple addresses as long as they're not within the same, or you can use the same address multiple times as long as it's not used within the same VRF. And we go ahead and we associate, we create a VRF. So remember we said we call our VRF customer A, or CST A. And then we associate a particular interface to that VRF. And that's all we have to do to create the VRFs themselves. But if we want to do some routing, we'll do that. And so we'll configure EIGRP routing. And I think we'll configure some Ospf routing because their configurations are different. And then interfaces can be physical or logical. So I could have a physical interface, or I could have like a VLAN SVI, a switch virtual interface. So here we'll just do the one router and we'll separate them out. Whoop, too far. So basic VRF configuration. Very simply put, we need to create the VRF. We have to do that first, otherwise we're going to get some errors. We do that using the IP VRF command. So it would be IP VRF and then the name of the VRF. And then in order to include an interface in a particular VRF instance, we have to apply that to the interface using the IP VRF forwarding. This should be bolded. I always bold the parts you have to do. So forwarding here should be bolded. And then the name of our VRF. And that's all we have to do. Now, if we want to go through and route, we've got to do some other things. And like I said, EIGRP and Ospf have different commands for that. So let's go over what we're going to configure. And basically, I'm just going to do what I said I was going to do in the last slide. I'm going to make this thing here one VRF instance. And he's going to be named CUSTA for customer A. And I'm going to make this one over here another instance. And we'll call him CUSTB. And then we'll assign our IP addresses over here. Remember I said we could use them. I want to use the same ones as long as they're not in the same VRF. So we're going to demonstrate that. And so we'll do 192.168, 2.0 here, 1 and 2, and then we'll do the same thing over here. We'll do 192.168.10, and then 2.0 here. It's not vital because you'll see it when I configure it, but this guy will be dot one end of everything, and these guys will be the dot two end of everything, so like 192.168, 2.2, and so on. And then we'll first configure it with EIGRP, and then we will remove that and configure it with Ospf just so you can see the different configurations, and then that'll be it. Our customer routers have already been configured the way they would normally be. So now all we need to do is configure our central router, the one in the center that we're going to break up basically into 2 virtual routers. So the first thing we have to do is we have to create our instance of our VRF. So we do IP space VRF and then give it a name. And it'll bring us into VRF configuration where we want to exit out because we want to configure our other VRF before we get going. We have to do this step first, otherwise it's going to balk at us. So IP VRF space and then CUSTB or CUSTB, and then we'll exit out. Now we've got to apply it to interfaces. Now I have to go back and remember. I have to look and remember which interface was which was connected to where. Interfaces are, oh, I've got to grab my pen back. This one's gig 01. Nope, sorry, not 1. Connected to R2 is gig 01. Connected to R3 is 2, and then 3, and then 4. So we'll put gigabit 1 and 2 into our cust A VRF, and we'll put gigs 3 and 4 in our cust B VRF. All right, so we said 1 and 2, right? IP VRF forwarding, forwarding, and then the name. And we have to give him an IP address, because we haven't given this one IP address yet. He's going to be, because once we did it was just going to balk at us. If we had put the IP address on there first, it would have just balked at us, gave us a little warning message, and we would have had to put it on anyway. So we'll just do IP address 192.168.1.1. We'll do a no shot. And then GI 0/2 will be our other one that's in cust A. IP VRF. Oh, forwarding seems to be escaping me as a word. And give it an IP address. He's going to be 192.168.2.1. And in GI 0, remember 3 and 4 are going to go into cust B. So again, IP VRF forwarding. It's case sensitive, you'll find in some spots, so it's interesting. And we give it an IP address. 3, what do we say 3 was going to use? It's going to use 1 or 2. Oh, I got to pull up my other router. So if we go to 5, so as I pull up 5, let's do a show IP route. Be a quick, easy way to see which ones are at this end. And 2 is on 5, which means 1 is on router 4. So gig 3 then is going to be 192 because that's the one connected to router 5. 2.1. Kind of cool, right? You remember from the good old days, they would have balked at you before and said there was a problem. So we do a no shut. Now I'll get this out of your way. And then we'll do our last interface, IP VRF forwarding, and the name, 192.168.1.1. All right, now we've created them all. Now we said we wanted to do some routing, right? Let's hit end first. Notice when you do a show IP route now, not even our connected networks are in there. This would be the routing table for our overall network, or overall router, sorry. There's nothing in there because now we have 2 separate instances of virtual routers, basically. Right, so now I have 2 routers running on one. So if I want to see it now, if I want to at least see the connected ones, we got to do a show IP route, VRF, and then the name. So now I see the interfaces and the addresses or networks associated to those interfaces. So let's hit an up arrow, do the same thing with customer A. You'll notice I'm using the same addresses. The difference is our interfaces will be different. One other thing I wanted to do before we get routing in is I wanted to get, no, I've got them. Never mind. It's in. I'm good. I'm pretty sure I'm good. We'll troubleshoot together if I miss something. So now let's go ahead and do our routing protocol. I'm going to do EIGRP first. EIGRP. And now we do it a little bit differently now. We're going to do it in the address family. IPv4, VRF, and then the name. Within there, then, we can announce our networks. 92.168.1.0. I hit the up arrow, we'll do 2.0. And we'll exit out. Ooh, forgot to provide our autonomous system. We actually need to do that. We'll do that in our address family command. IPv4, VRF, question mark. What did I didn't type it right. There we go. Should use tab more often because you can't mess up as much, right? IPv4 VRF test A autonomous system. And just give it autonomous system number 1. Yeah, these commands I'm sure didn't go away. We just do it again anyway. And you can see my adjacency came up with both my neighbors because remember R1 in the cust A VRF are connected to routers 2 and routers 3. And I said I already pre-configured them with EIGRP because what we were focusing on here is not how to configure EIGRP. We were focused on configuring VRFs and seeing how they can be separate instances, use same addresses, and things like that. So now let's also do IPv4 cust B VRF. And assign those networks. And we did see another adjacency come up. Awesome. Now let's type end. Big thing I wanted you to notice was the difference. So if we do a show run begin EIGRP, should bring us to that part where EIGRP starts. And just notice the difference. We created the VRFs, which is pretty easy, just a couple commands. And I can have a lot of them. And now we can't just do router EIGRP in the network. We actually use the address family command, VRF, the name of the VRF, and then assign the autonomous system number. And I can have multiple within the same instance of EIGRP. So let's do a show IP route. And again, nothing there. We already discussed that it wouldn't be, right? By just verifying, I like to go through and show you everything. If I had made a mistake or if I didn't put one of the interfaces in a VRF, then it could show up here. If it's not part of the VRF, it could show up here. So instead, we want to do what? Show IP route VRF and then the name. So if we look at cust A. The other thing is on each of these routers, I should have went back and I should have drawn that in. I apologize. On each of the routers, I put in a loopback address. So on the far router, I put another address in so that you could see, in fact, that not only do they have the connected routes, they have the routes connected there with, or they have the routes within that cust A VRF. But what they don't have are the other two, because remember I have 4 routers. Each of those edge routers, or I have 4 customer routers, if you want to call them, or edge routers. Each of those have a loopback. But the only thing that's going to be in cust A's are the two, for the 2 routers, router 2 and 3 that they're connected to, router 2, router 3. And it'll be true for the other side also. So if we type in our VRF, our other VRF name, and we'll see the same thing here. These are routers 4 and 5. You can tell I'm not real creative. 4 tells me it's router 4, and the number 5 here tells me it's router 5. These are the loopbacks we created, learned through EIGRP within our VRF, but they're not learning each other's information. And things aren't being routed in each other. They're only routed amongst those devices that are within that VRF. So I have customer A and I have customer B, and they're part of my service provider network, or in this case, we're using VRF Lite. We could have other things. I just use customers as an example, as it's a common one. And their routing tables and things are all separate. So there it is. It's pretty simple. There are many more things you could do with it, and like usually it would be used with VPNs over MPLS. And so then there's a few more commands there, but with VRF Lite, this is it. All right, so let's go ahead and let's switch to Ospf now, because the commands are a little bit different. So we do no router. Should move EIGRP first. We're not going to use it. And we do router Ospf. And here's where it's different. Router Ospf process, and then this is where we're going to specify the VRF that's going to be in there. Instead of doing an address family, we're going to do router Ospf1, VRF, customer A, and then advertise our networks. Or put our networks in there, 255. We'll put them in area 0. We're going to up arrow. We'll do 2. And let's type end. I'll get that out of your way. Now you'll notice I didn't show any OSPF adjacency or anything like that coming up. I got no commands that we have neighbors or, so if I do a show IP route VRF, and I don't have them, all I have is directly connected now. Reason being the other side, the routers that are in this VRF are currently running OSPF, so we've got to fix that. So let's go back and fix that. First we'll remove EIGRP, and we'll do router OSPF. Now this side isn't a VRF. This router is part of a VRF, but he's not a VRF, so I don't have to specify a VRF over here. 1.0. I think that's the one that's on that side. I got to try to remember. I'm pretty sure. Whoop. Area. And then remember I had a loopback on here. Oh, there we go. Look at that. Now we got a neighbor. Now we have an adjacency. We also have a loopback on here of 10.1.2 because this is router 2. Okay, so we're going to put that network in there. Show run begin. Show run begin OSPF, and that looks about right. Now let's go back to our router 1. Hit the up arrow, and now we do have our loopback OSPF routes. Now we're running OSPF in cust A right now. Actually, we're only running it in cust A on router 2 because we never switched to router 3, so we're only going to see router 2's loopback. But we could keep going like this and make this whole network OSPF also. The biggest thing, well, let's do one other thing. Let's do a show. I'm going to go to OSPF, okay? Let's do this again. Let's do it for customer B. So notice that we get an error. So I do a show run, and I still see I do have, I suppose I could use a better command than that. I always tell my students to use a better command than show run, but I do have that. The problem is I have to do a separate one for OSPF for each VRF. So OSPF 2, VRF, and now it's fine with it, right? We put our 2 networks that are in cust B VRF. So what I wanted you to see really here is how it's different, how OSPF and EIGRP are different. And now we have 2 different instances of OSPF for each of our, one for each of our VRFs. And that's it. In order for us, we could do some more verifications and things like that. I just wanted you to see the VRF configuration, understand the theory, which is not too hard. I mean, it has a really long name, but you know, if you think of it as like virtual routers, separate tables and things like that, and separating them out, much like VLANs, but at layer 3 instead of layer 2. I think the concept's relatively easy. The configuration's relatively easy. I mean, obviously in a larger, you know, network, a service provider network, and we add on top of that, you know, that VPN portion of it. Yes, this could become much more complex. So the VRF Lite is pretty simple. And that's it.